Hi everyone. I'll just give a quick review of what I was discussing in the last bit. So I said that the 2 points that I did not mention earlier on was number one, Martin Rodbell was the guy who discovered and characterized G protein coupled receptors in 1970s, and G proteins are heterotrimeric, which means they have three different subunits: alpha, beta, and gamma, and it is the alpha and the gamma subunits that are attached to the plasma membrane. Beta is not. And yes, it is the alpha subunit that has the guanine nucleotide binding site. So let me just write that here. Guanine nucleotide binding site. And this is the site where GDP or GTP are bound. Okay? So that's all about the general working of the G protein coupled receptor and the few little points that I wanted to discuss. Mm, Now I think we should discuss that heterotrimeric G proteins, they are of four different kinds. Okay, and so let's look at the four different kinds here. I'm just gonna erase this so I don't waste the slide. Okay. So the four different kinds of G proteins are GS, then there's the GQ, GI, and G 12 over 13. Okay, and I think it's a good idea to remember these. So GS, GQ, GI, and the way I remember it, well, 12 to 13 is pretty okay to remember, but I remember SQI sort of like squid, except that there is no U and there is no D, so I just remember SQ and I. It's a silly way of remembering it, but whatever works. Mm, Now let's look into GS protein. So GS family members couple receptors to adenylyl cyclase. So in the example that we did before, in understanding this whole thing, so this G protein would be a GSG protein, okay? So that would be for the couple receptors to adenylyl cyclase activated by G bound G alpha subunits. Okay? So that would be the typical example that we talked about. GQ family members contain G alpha subunits that activate phospholipase C beta. Phospholipase C beta. So these, in all the G proteins, it's the G alpha subunit that is doing the activation of effectors. For GQ, it is the effector would be phospholipase C beta. In short, it is referred to as PLC beta. It hydrolyzes, sorry, it hydrolyzes phosphatidylinositol. It's a pretty big word, so I'm just going to call it PI. Diphosphate, PI2P, producing inositol, and diacylglycerol, and inositol IP3. Okay, inositol triphosphate. So that would be GQ. GI subunits act by inhibiting adenylyl cyclase. Adenylyl cyclase. And then the G12, they are not so well characterized, so we don't really know a lot about them. Okay, so hopefully that has made sense. I think I kind of, pretty much it's all over the place. So what I'll do in the next slide is make a nice table and then go over it in detail. Just, well, not in detail, but just review it one more time. So hopefully it's more clear and hopefully it'll help you remember it better. And in the next video, I'll also talk about the function of the beta gamma subunits. What do these guys do? Okay, so in the next video. And that will be followed by bacterial targets. Okay, so see you guys in the next video.